Hello everyone, in this video we're going to review the AP Precalculus topic 1.1 to 1.6. Alright, question number 1. The graph of the polynomial functions f is shown above, where -5 less than or equal to s less than or equal to 5. So which means this is the domain of the function, right? So the function stops right here. The function f has local extrema at s squared -2 and s squared 2. So this is local maximum. This guy is local minimum, right? And the graph of f has a point of inflection at s equal to 0. So here's the point of inflection right here. Alright, on what intervals is f increasing? Alright, so in order to know if the function is increasing or decreasing, make sure you know the Christmas tree trick. Okay, so I have the Christmas tree trick right here. Okay, so you need to draw the tangent lines of the graph, right? So the tangent line like this. This is the first tangent line. This is the second tangent line. And this is the third tangent line. Now, if you see the graphs going this way, the tangent lines go in this way, the slope is positive. If the slope positive, the function is increasing, right? If the lines go in this way, the slope is negative. And if the slope is negative, the function is decreasing, right? So, look at this one right here, the function is increasing from -5 to -2 right here, right? From here to here. Alright, so it's going to be -5 to -2 union this guy right here. Alright, net 2 to 5, right? On what intervals is the graph of f is concave down? Okay, so if you see the graph go like this concave down, this guy's concave up, right? So this is down and this is concave up. You see that if you have half of the concave down like this or like this is concave down. This guy like this or like this, concave up, right? So we look at this one, it's gonna be from -5 to 1 right here, right? So if you look at this one, it's gonna be from -5 to 0 right here, right? The function is concave down, so it could be -5, 0. Alright, number 2 right here, I'm gonna leave it for you to practice. Now let's move on to question 3. The graph of h is shown above, has relative extrema as s equal -3 and s equal to 2. So s equal -3, we have the local minimum, right? And s equal to 2, we have the local maximum, right? And a point of inflection as s equal to -1. So s equal -1, the point of inflection right here. Alright, on what intervals is h increasing and concave down? Increasing and concave down. So again, you're gonna draw the tangent line, right? So you're gonna draw this guy, this tangent line, this tangent line, and this tangent line right here. Now increasing, which means the slope is positive. So only this guy and this guy right here, the slope is positive. Now if you have the tangent line right here, the slope is positive, but the function is concave up, right? This guy, the slope is positive, which means the function is increasing, but it's concave down, right? So it's gonna be from -1 to 2 right here. So it could be -1 to 2. Now question B. On what intervals is h decreasing and concave up? All right, decreasing and concave up. So we look at this one. This guy tells us the function is decreasing, right? And this guy right here, decreasing, right? But concave up, this guy is concave up, this guy is concave down, right? So decreasing and concave up should be this guy. So it can be negative infinity to negative 3 right here. So it could be negative infinity to negative 3. Now, on what intervals is h decreasing at a decreasing rate? All right, the function is decreasing, so we look at this guy right here, either this guy, right, or this guy. Now, at a decreasing rate, so you're gonna draw two tangent lines and you compare, right? So right here I have the first tangent line right here. Now I have the second tangent line. It's gonna be right here. All right. Use the Christmas tree trick again. All right. If the tangent lines go in this way, the slope is positive. The tangent lines go in this way, the slope is negative. All right. If the lines go in this way, and if the line is steeper, the slope is bigger, right? So tangent line is steeper, the slope is bigger. Now, if the line go this way, and then if the tangent line is steeper, the slope is smaller. Now we look at this one, we have two tangent lines right here, and then the function is decreasing, right? And then you look at this one right here, this guy right here, the first one right here, is steeper than the second one. So it's gonna be this one, steeper, the slope is smaller. So which means this guy increasing, right? The rate is increasing, right? But we need decreasing rate, so this is not the case. Now look at this one right here, we draw another tangent line right here. All right, and we see that this guy right here steeper than this guy, right? So this guy right here has a smaller slope than this guy, which means the slope is decreasing, right? So the answer must be 2 to infinity. You're gonna put infinity right here, positive infinity right here, and negative infinity right here. Now 3D, on what intervals is h increasing at an increasing rate? Now we look at this one right here. So we have two increasing interval right here, from negative 3 to negative 1, and from negative 1 to 2, right? So we're gonna explore each of them, right? Now first one, I'm gonna draw another tangent line right here. I see that the tangent lines go this way, which means the function is increasing, so I'm good with this one. Right, now I'm gonna check if the rate of change is increasing or decreasing. So I look at this one right here, I see that the tangent line is getting steeper, which means the slope is bigger. So the function has an increasing rate. So the answer must be this interval. So it can be negative 3 to negative 1. Alright, and if you do this one, the function is increasing at a decreasing rate from negative 1 to 2, right? So we only have one answer right here, negative 3 to negative 1. Determine if each of the following statement is true or false. Now question 4. The rate of change of the function case is increasing over the interval 4 to 6. So we look at this one 4 to 6. This is 4 and this is 6 right here. So this guy right here, yes, the rate of change of case is increasing. Yes, you can draw two tangent line and you see that the first tangent line right here and the second tangent line right here, and you see that the second tangent line is steeper than the first one, which means the slope is bigger, so the rate of change is increasing, right? So this is true. Now question number 5. The rate of change of the function k is negative over the interval negative 4 to 0. Negative 4 to 0, which means this guy right here. Alright, so the rate of change of the function k is negative. Yes, you can draw a tangent line. And you see that tangent line is going this way, which means we have the Christmas tree trick right here. So the rate of change of k is negative over this interval, so this is true. Now question 6. The function k is increasing at a decreasing rate over the interval 2 to 4. So 2 to 4, we have this guy and to this guy right here. Alright, so we draw one tangent line and we see that the tangent line going this way, which means the function is decreasing. But this guy say the function is increasing, so this is wrong. So this should be false. Now question number 7. The rate of change of the function k is positive and decreasing over the interval negative 6 to negative 4. So negative 6 right here, negative 4 right here. We have the function is going to be right here. Alright, so we're going to check. The rate of change of k is positive. So we draw the tangent line. And we see that the tangent line going this way, which means the rate of change is positive, which is good. This is right. And decreasing, right? We draw another tangent line. So it could be right here. And we see that the tangent line getting less steep, which means it has smaller slope. And then the function has a decreasing rate, right? So this is true. So question number 7 is true. Now question 8. The graph of the function k is concave down over the interval negative 4 to 4. So negative 4 to 4 is going to be right here to this one right here. Right, so this is not the case because this guy right here, from here to here, the function is concave up. And from here to here, the function is concave up. So that's wrong. So number 8 is false. Question number 9. The function k is increasing over the interval negative 6 to negative 4. Negative 6 right here to negative 4 right here. So this is negative 6, this is negative 4. The function is increasing, yes, because we can draw a tangent line. And we see that tangent line is going this way right here. So the slope is positive, which means the function is increasing from negative 6 to negative 4. And now check 4 to 6. 4 to 6, it will be from here to here. And we draw another tangent line. And then yes, the function has the tangent line has the positive slope, so the function is increasing. So number 9 is true. Now question 10. The function k is negative and increasing over 4 to 6. Negative and increasing over 4 to 6, so 4 to 6 right here. Right? The function k is negative. So we check this one. We see that the function is below the x-axis. So this is negative. So this is true. Right? And increasing. Right? We draw another tangent line. We see that the tangent line going this way. So which means it has the positive slope. So which means the function is increasing. Right? So question 10, this is true. Now question 11. the function k is decreasing at a decreasing rate over the interval negative 3 to 0 and 2 to 4, right? So negative 3 to 0, we're gonna draw this one. Negative 3 to 0 is gonna be right here, and 2 to 4, 2 to 4 is gonna be right here. All right. Now we're gonna check if the function is decreasing at a decreasing rate over these intervals. So we draw the tangent line, and we see that tangent line going this way, which means the function is decreasing. Good. All right. We draw another tangent line right here, and another tangent line right here, and we see that the slope getting bigger because the tangent line is going this way, and then if the tangent line steeper, the slope is smaller, right? Now this guy right here less steep than this guy, which means the slope is bigger, so the function is decreasing at an increasing rate. But it say the function is decreasing at a decreasing rate, so this is false. Number 12. The function k is positive and the graph of k is concave up over the interval negative 3 to 0. Negative 3 to 0, so we have this guy right here. Alright. The function is positive, yes, because it's above the x-axis, so the function is positive. And the graph of k is concave up, yes, this is concave up, right? We have like something like this, or something like this. This is concave up. So the answer number 12 is true. Now number 13, the function is positive and the rate of change of k is positive over the interval 4 to 6. So 4 to 6 is going to be right here. Alright, so the function is positive. That's wrong, right? Because the function is below the x-axis, so this is negative. So this is false. Alright, so we know that the average rate of change formula is going to be f of b minus f of a over b minus a over the interval a, b, right? So we look at the first one right here, number 14. Find the average rate of change of the function f of s over this interval right here. So we have average rate of change is going to be f of 2 minus f of 1 over 2 minus 1. So we just substitute into the function right here. So we have 2 times 2q minus 2 plus 1. Alright, don't forget parentheses, minus another parenthesis. So it could be 2 times 1q minus 1 plus 1 over 1, right? So if you simplify this one, it turns out to be 13. Now, question number 15 is going to be similar to the question number 14, so I'm going to leave it for you, okay? Now, question number 16, find the average rate of change of the function g of s over the interval negative 1 to 4, right? The function g of s, this is a piecewise function, right? Alright, so now we're going to use the formula. It's going to be average rate of change is f of 4 minus f of negative 1 over 4 minus negative 1. So it turns out to be f of 4 is going to be, because 4 greater than 3, so we're going to use the second one right here. So it's going to be 4 squared plus 2 all together, subtract f of negative 1, which is less than 3 right here. So we're going to use the first one right here. So it's going to be 4 minus 2 times negative 1 over 4 minus negative 1 should be 5, right? So if we do this one and we simplify this one, it turns out to be 12 over 5, right? Now, question number 17 is similar to question number 16. I leave it for you, okay? Now, question number 18. Find the average rate of change. Now, question number 17 and 18, similar to question number 16, right? So I just leave it for you. Now, question number 19. Find the average rate of change of the function k of s over the interval -2 to 1, right? So we have the average rate of change is k of 1 minus k of -2 over 1 minus -2. So it's going to be k, look at the function k right here, k of 1 is going to be 4 minus k of -2 is going to be 8 over 3, right? So it's going to be -4 over 3, right? Now, look at number 20. Find the average rate of change of the function p of s over the interval -1 to 5. So -1 to 5 is going to be right here. Alright, so we have the average rate of change formula is p of 5 minus p of -1 over 5 minus -1. So p of 5, we look at this one, we see that it's going to be 3, right? So this guy is going to be 3 minus p of -1. P of -1 is going to be 1 right here. Over 5 minus -1 is going to be 6. So it could be 1/3. Now number 21, I leave it for you, okay? Number 22 to number 27, determine if the following functions could be concave up, concave down, or neither. In order to do this one, we need to calculate the average rate of change. If the average rate of change is increasing, the function is concave up. So average rate of change increasing, the function is concave up. If average rate of change is decreasing, the function is concave down. And if average rate of change both increasing and decreasing, the function is neither. Alright, so we look at this one, we see that now we need to find the change of this one. So does that mean in order to get 4 from 3, I'm going to add 1, right? This one I'm going to add 2, this one I'm going to add 3, and this one I'm going to add 6, right? So in order to find the average rate of change, I'm going to take 1 and divide by the equivalent input intervals right here. This one 1, this one 1, this one 1. So the average rate of change, the first one is going to be 1 over 1. The second one 2 over 1. The third one 3 over 1. The last one 6 over 1. And you see that average rate of change is increasing, right? So because average rate of change is increasing, the function is concave up, right? In order to get 1 from -3, I'm going to add 4. And this one I'm going to add 6. I'm going to add 4 and I'm going to add 4. So the average rate of change is going to be 4 over 2, right? Because the equivalent input interval is going to be 2, right? So it could be 2. Now you have another interval right here, 1 to 7 right here. So average rate of change is going to be 6 over 2 and it's going to be 3. And this one right here is going to be 4 over 2. And the last one right here, 4 over 2. So you see that, right at in this table, the function is both have the average rate of change increasing and constant at the same time. So it should be neither. 7. And this one 5. This one 2. This one 1, right? So the average rate of change can be 7 over 3, 5 over 3, 2 over 3, and 1 over 3. And you see that the average rate of change is decreasing, right? So the function is concave down. Alright, so I'm going to leave number 25, 26, and 27 for you, right? Now let's take a look at the 28 to 31. Determine the least possible degree of the polynomials. Right, so you just find the change in y over the equivalent input intervals, right? So we look at this one right here. In order to get negative 3 from negative 3, you just add 0, right? This guy right here, you just add 2. Four. This guy right here, you add 7. This guy right here, you add 9. And this guy right here, you add 10. Alright, so these output are not the same. So you keep calculating, right? So in order to get 4 from 0, I'm going to add 4. This guy, I'm going to add 3. This guy, I'm going to add 2. And this one, I'm going to add 1. They are not the same, right? So next, in order to get 3 from 4, I'm going to subtract 1. This one, I'm going to subtract 1. This one, I'm going to subtract 1. So after the first, second, and the third difference, all the output right here are the same, right? So the function has the degree 3. Because the third difference are constant. Now look at number 29. Over the equivalent input intervals right here, we're gonna calculate the difference of the output. So in order to get 8 from 12, I'm gonna subtract 4, subtract 2. Now look at number 30. Alright, over the equivalent input interval, we have the change in the output, right? So this one subtract 5, subtract 2, plus 1, plus 5, and plus 11, right? Next one, we're gonna add 3. This one we're gonna add, now we're gonna add 0, 1, 2, right? Add 1 and then add 1. So after 1, 2, 3, 4 times calculate the difference of the output, we have the same constant right here. So the function has degree 4. 1, it's gonna be 3, it's gonna be 5, it's gonna be 7, and it's gonna be 9, right? The change in output is gonna be 1, 3, 5, 7, and 9. Now we're gonna calculate the average rate of change. So it can be 1 over 1. It's gonna be 1. The second one, 3 over 3. It's gonna be 1. The third one, 5 over 5. It's gonna be 1. The next one, 7 over 7. It's gonna be 1. And the last one, 9 over 9. It's gonna be 1. So because the average rate of change is a constant, so the function is a linear, right? So this is degree 1. Now let's move on to question number 32 to 38. So question number 32 to 38. Determine if the following functions are even, odd, or neither. So keep that in mind. We have the formula if f of negative s is negative f of s, the function is odd. If you have f of negative s is f of s, the function is even. Right, so we're going to check this one. So we have y equal this one, right? So I just say f of so I just name this function as f of s, right? So I'm going to check f of negative s. It's going to be 2 times, right? When we see s, I substitute negative s, right? So I have negative s cubed minus 3 times negative s plus 9, right? I'm going to simplify. Negative s cubed is going to be negative s, so it could be negative 2s cubed. Negative 3 times negative s, it could be plus 3s plus 9, right? So because this one right here is not the same thing as original one, right? No, it's not going to be negative f of s, so this one should be neither. Now, question number 34. We start from f of negative s. It's going to be negative s to the 4th minus 3. Make sure you put the parentheses. So it could be because this one has the even power. So any negative number raised to the even power is going to be positive. So we have s to the 4 minus 3. So this go back to original one right here. Right? So we have this one is going to be f of s. So we just prove that f of negative s equals f of s. So the function is even. Right? Now the last one right here, we have g of negative s. It's going to be negative 6 times negative s, all together raised to the power 5, plus 2 times negative s cubed minus negative s right here, right? So this guy turns out to be negative s raised to the 5th. Alright, so it's going to be negative s because this is odd power. So negative s is turned out to be negative s to the 5th, right? So negative s to the 5th multiplied by negative 6, so it could be 6s to the 5th. This guy, negative 2s cubed, and this one plus s. Now I can factor the negative side out, so it could be what? Negative side, I put this outside, so this guy turned out to be negative 6s to the 5th plus 2s cubed minus s, right? So you see the inside right here, this is actually the function g of s, right? So I rewrite the negative side outside. This guy actually the function g of s right here. So I just prove that g of negative s equals negative g of s, so the function is odd. Now look at number 36. Keep in mind the function is even, it's going to be symmetrical about the y-axis. If the function is odd, it's going to be symmetrical about the origin. Alright, the point right here, it's going to be 4, 3. So, because we have the opposite point right here, it's going to be negative 4 and negative 3. Right? So, which means the function symmetric about the origin right here. So the function is odd. We look at number 37 right here. Right, the function is not symmetric about the origin, not the y-axis, so this is neither. Number 38, the function symmetrical about the y-axis, right? Look, if we have the point right here, we have the opposite point right here. So they are symmetrical about the y-axis, so this is even. Alright, question 39 to 42. The polynomial function k is even. right? So this guy is even. And the polynomial function p is odd, right? Question 39. Find the values of a and b in the table above. So we need to find a right here, and we need to find b right here. So we know that because the function k is even, so we have k of negative s equals k of s, right? So we look at this one right here, this guy and this guy right here. So we have k of negative 3 equals 8. And then k of 3 right here must be the same thing, equals 8, right? So the answer for 8 right here equals 8. Now, look at this one. Because the function b is odd, so we have p of negative s equals negative p of s, right? So we have p of b equals 3 right here. And then we have p of negative b is negative 3, right? So we look at this one right here, right? Negative b, so negative 3 is going to be right here, which means we have negative 4 right here. So we just equate this. So we have negative b equals negative 4, and then b equals 4. So the answer is 4. Now question number 40. K of 2 plus p of negative 2. K of 2 is going to be the same thing as k of negative 2 because the function is even, right? P of negative 2 the same thing as negative p of 2, right? Because by the formula, the function is even, we have f of negative s equals f of s. If the function is odd, f of negative s is negative f of s, right? So we just substitute values. Negative 2, k of negative 2 equal negative 6, so it could be negative 6, minus p of 2 is going to be 7, so minus 7, so the answer is negative 13. Now question number 41. K of negative 1 is the same thing as k of 1. So k of 1 is going to be 4. Now p of 3 is the same thing as negative p of negative 3, right? So it's going to be negative p of negative 3 is going to be 2, so it could be negative 2. And the last one, find the average rate of change of p of s over the interval negative 5 to 5, right? So we have average rate of change is p of 5 minus p of negative 5 over 5 minus negative 5. Now we look at this table, we don't have p of 5, but we know because the function p is odd, so p of 5 is the same thing as negative p of negative 5, right? So we just plug it in over here, so negative p of negative 5 minus p of negative 5, right? Over 10, right? So p of negative 5 is going to be 4, so it's going to be negative 4 minus 4 over 10. So it's going to be negative 4 over 5, right? Graph of the polynomial function f is shown above, where the function is defined between negative 6 to 6, so we have the endpoints right here. Use the graph of the function f to answer the following. Now, f has a local minimum at, right? Local minimum is going to be this guy right here and this guy right here. So, at s equals negative 4 and 3, right? So, negative 4 and 3. F has a local maximum at s equals right here. Local maximum s equal to 0. This guy right here, negative 6. And this guy right here is going to be 6, right? The absolute maximum of f is the highest value right here. So the highest value right here is 5. At s equal to 6. The absolute minimum of f is the lowest one right here. So it's going to be negative 5. At s equal to negative 4. So it's going to be negative 4 right here. Now look at the second one. The function g has local minimum as this guys right here. So it's going to be at s equal to 4. And this guy right here, s equal to negative 3. The function g has a local maximum at this guy right here, s equal to negative 5. And then this guy right here is going to be 0. You cannot count this one because you see the arrow, which means the graph keeps going up, right? The absolute maximum of the function g is none. Because this guy keeps going up, you don't have the highest point, right? The absolute minimum of the function g is this guy right here, right? It's going to be negative 3 at s equal to 4. Alright, number 3, I'm going to leave it for you. This is similar. Number 4, the graph of the polynomial function k is shown above. Which of the following could be an expression for k, right? So, we need to know that this guy and this guy have the same end behavior, right? So, which means the degree must be even, right? So, we know that this guy even. Now, they both pointing up, so which means the leading coefficient is positive, right? So leading coefficient is positive, right? And we look at the 0 right here. We have 1, 0, 2, 0, and 3, 0. But this 0 right here, because the function powers off the x-axis, so this guy multiplicity of 2. Alright. So we look at this one right here. We see that the leading coefficient is negative. We cross this one out. Alright. Now, this guy right here. We look at question D right here. We see that. We look at the answer D right here. We see that the power right here, power 1, and power 1 right here. So it can be odd power. So this is wrong. Right. We need even power. So we only have this one, and we just check the 0, right? So the 0 right here, negative 4, right? So in order to write the polynomial, it should be as minus the 0. So which means minus negative 4, right? And right at this 0 right here, we have multiplicity of 2. So this one must be square, right? So negative turns out to be positive. The answer should be B. Now look at this one right here. The graph of the polynomial function p is shown right here. Which of the following could be the expression for p, right? So we look at this one. This guy and this guy have the opposite end behavior, which means the function is odd, right? And because the left-hand side right here pointing up, the right-hand side pointing down, the leading coefficient is negative, right? Keep that in mind. So we look at this one, we see that leading coefficient is positive. Leading coefficient is positive, so this is wrong, right? And we have 3, 0 right here. 1, 2, 3. Alright, so the degree must be 3, right? And we look at this one, degree is 4, right? This is 2, this is 1, this is 1, so degree 4, this is wrong. So the answer must be C. And we check this, the 0 right here, negative 3, so which means S minus negative 3 times the second 0 right here, S minus 0, right? And the third 0 right here, S minus 2. And if we simplify, it's going to be right here. Alright, let's move on to question number 6 right here. Alright, we look at this one. This guy and this guy have the same end behavior, right? So the function is even. And then because they're both pointing up, which means the leading coefficient is positive, right? If they're pointing down, the leading coefficient is negative, right? So we look at this one right here, we see that the function has two real zero right here. And they both bounce off the x-axis, right? So we have s minus negative 2, right? And they both bounce off the x-axis, so this guy must have the multiplicity of 2. So this guy multiplicity of 2, and then this guy s minus 3 power of 2, right? And we know that the final answer must be even degree. And then, of course, the function has the imaginary root, right? So we look at this one right here. Leading coefficient is positive. We need to cross out this one. It should be even degree, right? So this one right here, right? At least we have 4 right here. So we cross out A, right? Now we look at B and D right here. So you need to be careful because the function has imaginary roots right here. So the answer must be D. Now question number 7. We need to find x where the function g of x greater than 0, right? So the function greater than 0, which means it's above the x-axis, right? So it's going to be this guy right here. Alright, so we put negative infinity right here, positive infinity, and negative infinity right here. So which means we need to find the domain of this one. So it could be negative infinity 2, 3, right? But because we don't have the equal sign, which means you don't include the 0. So we have the 0 right here as negative 2. We need to exclude this one. So it's going to be negative infinity 2, negative 2, union negative 2, 2, 3. Right, so you need to be careful. Now question 7b, g of x less than or equal to 0, which means the guy below the axis right here. Alright, so it's going to be from 3 to infinity, right? Now, because we have the equal sign, which means we're going to include the 0, so the 0 is 3, so we have the bracket right here. And we look at this one, we need to include the 0 right here too. So this guy union negative 2. Now look at question 8 right here. Alright, question 8, I'm going to leave it for you to practice. Alright, question 9. We need to solve the inequality right here. So the first step you need to do is to find the 0 of this one. So x plus 4 equal to 0. And then s equal to negative 4. Now s minus 3 equal to 0. And then s equal to 3. The last one s plus 1 equal to 0. And then s equal to negative 1. Now you need to draw the number line. And then you need to place all the 0 on the number line. So I have negative 4, negative 1, and 3. The 0 must be in increasing order, so keep that in mind. The left hand side right here, you put negative infinity. The right hand side, you put positive infinity. Now, you're gonna pick a number within any interval, and then you check to see if within that interval is positive or negative, right? So I look at this one right here, from negative 1 to 3, and I pick a 0, right? So I substitute over here. So I have 0 plus 4, 0 minus 3, 0 plus 1, right? So I have 4 times negative 3 times 1, right? And I look at this one, it's going to be negative 12, and it actually is negative, right? So within this interval right here, I have negative, right? So I put a line right here, put a line right here, right? Now, if you see the multiplicity of each linear factor right here as an odd number, and then you keep changing the sign, right? This is negative, this guy positive, this guy negative, this guy negative, this guy positive. All right, so finally we're gonna look at this one right here. We need this guy to be greater than or equal to 0, right? So we only pick the positive one right here. Okay, so the answer must be negative 4 to negative 1, right? And we have the equal sign right here, which means we need to include it with the bracket union 3 to infinity. Right at negative infinity or positive infinity, you cannot put a bracket, you must put parentheses. So keep that in mind. Alright, so if you see the leading coefficient right here, negative number, multiply both sides by negative 1, right? So I have 3 times s plus 2 times s minus 1 times s minus 5 greater than 0. You need to flip the inequality symbol, right? So then you need to find the 0 of each of these linear factors right here. So I have 0 of this one is going to be negative 2, this guy 1, and this guy 5, right? So I place this guy on the number line, right? Now I need to pick a 0 within this interval, right? So I substitute over here. I have 3 times 2 times negative 1 times negative 5, which is positive, right? So this guy must be positive. And then I look at this one, I see that they all have multiplicity of odd number, right? So I keep changing the sign like this. Alright, so I look at the second inequality right here. Don't look at the first one. Look at the second. I need this one to be greater than or equal to 0, right? So the answer must be this interval and this interval right here. So because I don't have equal signs, so I don't need to include the endpoints, right? So it's going to be negative 2 to 1 union 5 to infinity. Alright. Now look at number 13. So we need to find the 0 of this one. So it will be s equal to 0 with multiplicity of 2, right? Right here. And then s equal to negative 7 for this one. And then s equal to 4, right? So I draw the number line. So I need to place negative 7, 0, and 4 over here. Right? I put a line right here. The left hand side I put negative infinitive, the right hand side I put positive infinitive, right? So I look at this one right here. I need to pick a number. I pick number 1 right here. I substitute 1 into this inequality. So I have negative 3 times 1 times 8 times negative 3, right? So it's going to be positive, right? So this guy positive. I put this positive, right? Now 4, you look at 4 right here. This is multiplicity of 1, right? So I keep changing the sign. Now 0 right here, multiplicity of 2, and then the sign doesn't change. This guy positive, this guy must be positive, right? Keep that in mind. When the graph passing the 0 with multiplicity even, right, the sign does not change. Keep that in mind. And then this guy right here, negative 7, this multiplicity of 1, so this guy change, right? Negative. Now I need this guy to be greater than or equal to 0, so which means my answer right here, right? So it's gonna be negative 7, comma 4, right? And then I have the equal sign right here, so I need to include the endpoint. All right. Now the last one right here, I need to find the 0 of this one. So the 0 of this one is gonna be s equal to 0. Multiplicity of 3, so I don't care, right? Keep in mind, I only care about the multiplicity of even power, right? This guy, s equals negative 8 multiplicity of 2, right? And s equals 5 multiplicity of 1. S equals 1 multiplicity of 2, right? So I draw a number line. I place all these number on the number line. So it could be negative 8 go first, and then 0, next one, 1, right? And then the last one should be 5, right? So I draw the line right here. Put positive infinity right here, negative infinity right here. So now I'm going to pick a number 2 within this interval, and then I'm going to substitute over here. So I have 4 times s cubed, which means 4 times 2 power of 3 times 10 power of 2 times 2 minus 5 is going to be negative 3 times 2 minus 1 is going to be 1, so 1 square. So this guy positive, 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 this guy negative, right? So this guy must be negative, right? So the answer is negative. So this is negative. Now, you need to be careful. Look at 5 right here. Okay, so this is the 0, right? S equal to 5. This guy multiplicity of 1, right? So I keep changing the sign. S equal to 1, multiplicity of 2. So the sign doesn't change. So it could be negative right here. S equal to 0, right here, multiplicity of 3. So because this is odd multiplicity, right? So this guy right here keep changing the sign, right? Because multiplicity of 3. Now negative 8. Negative 8, which means the 0 of this one right here, multiplicity of 2. So this guy doesn't change the sign, so this guy positive, right? Now I need to conclude. I need this one to be less than or equal to 0. So the answer must be this right here, right? So it's going to be 0 to 5. Now I need to include the endpoint. So it could be 0 to 5 right here. And then right here, you see this guy multiplicity of 2 right here. Right, s equal to negative 8 right here. This guy make the inequality equal to 0 right here. So this is gonna be union to negative 8. Alright, let's move on to the next one. Number 15 right here, we need to find all real zero and indicate the multiplicity of each zeros, right? So the first one, 0 is 3, right? Because we let s minus 3 equal to 0, s equal to 3, with multiplicity of 4, right? The second 0 is going to be negative 2, multiplicity of 1, right? Because this is power 1. This guy same thing, power 1. So this can be 1 multiplicity of 1, right? This guy right here, the 0 right here, s right here equal to 0. So the 0 should be 0 multiplicity of 1. The second one, negative 3 multiplicity of 1, right? This was 1. And the third one is going to be 2 multiplicity of 3, right? Okay, so this one right here, I'm going to leave it for you as a practice, right? So I look at number 19 right here. Now this one, you need to factor this one out, right? So s squared minus 9, you're going to use the formula a squared minus b squared equals a minus b times a plus b, right? So this one is going to be s minus 3 times s plus 3, right? And then this one right here, I use complete square formula. So it could be a squared plus 2ab plus b squared is going to be a plus b all together square. Or you can factor trinomials and you still get the same thing. So it's going to be s plus 3 altogether square, right? So I'm going to combine. So s minus 3, right? And this guy s plus 3 times s plus 3 square is going to be s plus 3 cubed, right? So the 0 right here, the first 0 is going to be right here. S minus 3 equal to 0, so s equal to 3 with the multiplicity of 1, right? This is 1. And then the second one, s equal to negative 3 right here with the multiplicity of 3, right? Alright, the next one, number 20 right here. I need to use the difference of two squares to factor this one. So it could be equal to negative 2s times s plus 2 times s minus 2, right? And this one right here, it turns out to be complete square. So if I have a square minus 2ab plus b square, it's going to be a minus b altogether square, right? So this guy turns out to be s minus 2 altogether square. Now this guy right here, I use the s method to factor this one. So I put c right here, it's going to be negative 8. And I put b right here, it's going to be negative 2. I need to find two integers that multiply equals negative 8 add up to negative 2, which is negative 4 and 2. So this guy turns out to be s minus 4 times s plus 2, right? So then I'm going to combine. I have negative 2s right here. Now s plus 2 right here, it turns out to be s plus 2 square, right? S minus 2 right here, I combine this s minus 2 cube, right? And the last one should be s minus 4, right? So we have the first 0. Let's s equal to 0 right here, this guy right here. So s equal to 0, and this is multiplicity of 1. Second one, s equal negative 2, multiplicity of 2. Next, s equal to 2. This guy right here, multiplicity of 3. Next, s equal to 4. Multiplicity of 1, right? Let's move on to number 21 right here. So I just factor this one out. So it's going to be s times s squared minus 3s minus 10. And then times s squared plus 7s plus 10, right? So the first one right here, I use s method right here. So I put negative 10 right here, negative 3 right here, right? I need to find two integers multiply equal negative 10 add up to negative 3, which is negative 5 and 2. So this one can be written as s times s minus 5 times s plus 2, right? Now the second one right here, I need to find two integers multiply equal to 10 add up to 7, right? So it could be 5 and 2, right? So it could be s plus 5 times s plus 2, right? So I can rewrite this one as s plus 2 is going to be s plus 2 square, right? And then s minus 5 times s plus 5, right? So I need to find the 0, right? So the first one is going to be s equal to 0, this one right here, multiplicity of 1. S equal to negative 2 for the second one right here, multiplicity of 2. Next, s equal to 5, multiplicity of 1, right? And the last one, s equal to negative 5, multiplicity of 1, right? This is the power of 1. Now, let's move on to number 22 right here. We're going to factor this one out. So it could be s times s squared plus s minus 12. And this one factor s squared out. So it could be s squared times s squared minus 9, right? So you need to factor this one using s method. Like what I did right here, it turns out to be s times s plus 4 times s minus 3. And this one right here, s squared and s right here, I combine, it's going to be s cubed. and this guy turned out to be s minus 3 times s plus 3, right? Okay, so you need to find the zero. So the first one s equal to 0, multiplicity of 3. The second one, you're gonna combine this guy and this guy right here, so it can be square, so I don't need to write this one. So it can be s equal to negative 4 multiplicity of 1, s equal to 3 multiplicity of 2, and the last one s equal to negative 3 multiplicity of 1, right? This is power 1, this is power 1. Okay, so the last 23 and 24, I leave it for you to practice. Now let's move on to question number 25. So, given limit of the function f of s when s approaches negative infinity equals negative infinity, and limit of the function f of s when s approaches positive infinity equals negative infinity. So, the polynomial function f has n behavior above. So which one could be, right? So we look at this one, we see that limit of the function f of s when s approaches negative infinity equals negative infinity. So we need to sketch the rough draft right here. Alright, so we see that this one is y, this one is s. We need to put positive infinity right here. This guy negative infinity, this guy negative infinity, and this guy positive infinity, right? So we see that when s approaches negative infinity, which means s going this way, the function approaches negative infinity, the function going down. So which means the graph should be something like this, right? Now when s approaches positive infinity, the function approaches negative infinity, right? Like this. So the end behavior should be something like this. So this guy, and this guy have the same end behavior, right? So which means we know that this is even degree, right? And then we see that they both pointing down, which means the leading coefficient is negative, right? Negative. So we look at this one, even power, so we need to cross out B and D, and leading coefficient is negative, so we're going to pick C. The answer A is wrong, right? Now number 26, we do exactly the same thing, right? So we sketch this one, so this is S, this is Y, so we're going to put positive infinitive, negative infinitive, positive infinitive, negative infinitive, right? So limit of the function g of s when s approaches negative infinity is positive infinity, right? So s approaches negative infinity, right? The function approaches positive infinity, it could be like this. Alright, so the end behavior should be something like this, right? Now, when s approaches positive infinity, this way, the function approaches negative infinity like this. So the other end behavior should be like this, right? So we see that they have opposite end behavior, which means it should be odd degree, right? Okay, and then because the function pointing up to the left, which means the leading coefficient is negative. Alright, so we look at this one right here, odd degree, we need to cross out this guy and this guy. Leading coefficient is negative, we need to pick D. Now number 27, we need to sketch the graph, right? So this is S, this is Y, and then we need to put positive infinity right here, positive infinity, negative infinity, negative infinity, right? Now, when s approaches negative infinity, s going this way, the function approaches this way, right? So we have end behavior should be like this. And s approaches positive infinity, the function approaches positive infinity, So the at the end behavior should be like this. So they have opposite end behavior, which means this is odd degree, right? And then because the left hand side right here pointing down, which means the leading coefficient is positive, right? So based on this information, leading coefficient is positive. So we need to eliminate C and A, right? Because we have -2 and -2 right here. Now we check the power. This is 5, this is 2, and this is 1. Add up to 8, so this is wrong, right? And the last one right here, 5, 2, and 2 right here is going to be 9. And leading coefficient is positive 2, so the answer must be D. Alright, the last one, we have let's case of s equal this one, and which of the following pairs of statement both about the end behavior of k is correct, right? So we look at this one right here, the highest degree right here. So we see that the highest degree is gonna be 4, right? So we see even. And then the leading coefficient is negative, right? So we know that the degree is even, so they both pointing up or pointing down, like this. Okay, and then because the leading coefficient is negative, right? Leading coefficient is negative, so we're gonna pick this one right here. So which means when s approaches negative infinity, the function approaches negative infinity. When s approaches positive infinity, the function approaches negative infinity, right? So s approaches negative infinity, function approaches negative infinity. So the answer is A. Now let's move on to number 29. Given the table right here, which of the following claim and explanation statement best fits the data, right? So question A, f is best modeled by a linear function because the rate of change over consecutive equal length input value intervals is a constant. We're gonna check this one right here. We see that this one adds 2 each time, right? And the right hand side right here, negative, in order to get -1 from -2, we're gonna add 1, right? And this one we're gonna add 4, right? So this is not linear, right? Because 1 divided by 2 is gonna be 1/2. 4 divided by 2 is gonna be 2. The average rate of change is different. It's not a constant, so this is wrong. Now question B, f is best model a linear function because the rate of change over consecutive equal length input values interval is a linear, right? This one at 7, right? So 7 divided by 2, it could be 7/2. If question A is wrong, question B must be wrong, right? Because the function is best modeled by a linear function, the rate of change over consecutive equal length input value intervals must be constant, right? So this is not a linear, so this is wrong. Now question C, f is best modeled by a quadratic function because the rate of change over consecutive equal length input value interval is a constant. No, this is not right, right? It must be linear, right? Yes, this is right. So we're going to check this one right here. We see that 4/2 is going to be 4/2, right? This is 7/2 and this is 10/2, right? Now we need to find the chain of this one, right? So this one right here, in order to get 4/2 from 1/2, I'm gonna add 3.5, right? This one I add 3.5. This one I'm gonna add 3.5, right? So this one tells us the answer must be D. We look at this one right here, we see that every single time we're gonna add 10, right? Okay, the right hand side right here, this guy decreasing by 40, this guy decreasing by 20, this guy decreasing by 10, and this guy decreasing by 5, right? So I need to find the rate of change. So this one, the rate of change is negative 40 divided by 10. This guy, negative 20 divided by 10. This guy, negative 10 divided by 10. And this guy, negative 5 divided by 10. And I simplify this one, it's going to be negative 4, negative 2, negative 1, and negative 1/2. And you see that average rate of change is increasing, right? Negative 4 to negative 2 to negative 1 and negative 1/2, which is increasing. So because the average rate of change is increasing, the function could be concave up, right? So the answer must be B. Now let's move on to the next question. The graph of the function f is shown above. Which of the following statements about the function f is correct? So the function f is positive and increasing. No, this is not positive. It's only positive in this interval only, right? So this is wrong. The rate of change of the function f is positive and increasing. Yes, you can draw the tangent line. You see that the Christmas tree say if the tangent line is going this way, the slope is positive. And if the slope is positive, the rate of change is positive. Right? And if the rate of change is positive, the function is increasing. Right? So this is true. Now the function is increasing, so the answer must be B. Okay, question number 32. The graph of function g is, which of the following statement is true about the function g? Question A. The function g is an even function. Yes, because they have the same end behavior. And the rate of change of g is increasing. Now we need to draw the tangent line right here. The first tangent line, the second tangent line, and the third tangent line right here. You see that if the tangent line is going this way, the slope is positive, right? This guy 0, this guy is negative, right? So from left to right, the rate of change of the function g is decreasing, right? So this is wrong. Question B, yes, that's right. The rate of change is decreasing. The function is even. Now question 33, the function h is increasing. We draw a tangent line. Yes, this is, the slope is positive. The function is increasing. Yes. And the rate of change of h is increasing. We just draw another tangent line. We see that. Another tangent line right here, and you see that the tangent line getting less steep, which means the slope is smaller. Rate of change of the function h is decreasing, so the answer A is not right. The answer must be B right here. Decreasing. The function is increasing. Now question 34 right here. The function k is increasing. We draw the tangent line right here, and you see that the function, the line is going this way, the slope is negative, which means the function is decreasing. So we need to eliminate A, B, right? Now we draw another tangent line right here. We see that the tangent line getting less steep, and then this going this way right here, right? The tangent line is steeper, the slope is smaller, right? So which means the slope of this guy right here is less than this guy right here, which means the function has an increasing rate. So the answer must be C. Now let's move on to the next one. So we are at the home screen. We need to add graph right here, and we input the function. It's going to be negative plus 33.1. Okay, so you hit enter. Alright, so it's going to be like this. Now we need to restrict the domain from negative 3 to 3. Alright, so we need to hit menu, window, zoom right here. And then we're going to go to window setting. Right here, as min we put negative 3, and as mask we put 3. right? And y means y max, we just leave it. So we hit enter. So it's going to be like this. The function f has a relative minimum. So we have two relative minimum. The first one is going to be right here, and the second one is going to be right here, right? So relative minimum right here. We just hit menu, analyze graph, and minimum right here. Okay, we move the line to the left of minimum, hit enter. Move the line to the right of minimum, hit enter. So it could be negative 0.718. So it could be negative 0.718. So keep that in mind. The question asks you to find the relative minimum as the value of s right here. And the right hand side right here, we know that this is the lowest point right here. It's going to be at 3 right here. So okay, now relative maximum, we do exactly the same thing. We hit menu, analyze graph, maximum, move the line to the left up, maximum, move the line to the right. So it could be 1.99 right here. So it could be 1.99. And the left one right here is going to be at s equal to negative 3, right? So negative 3 right here. On what intervals is the function is increasing, right? The function is increasing from the interval negative 0.718 to 1.99, right? This one right here, the middle one right here, because the tangent line has the positive slope. So we have the interval negative 0.718 to 1.99, right? Now, on what intervals is the function f is decreasing, which means the other one right here. It's going to be negative 3 to this one, and it's going to be from 1.99 to 3, right? So it could be negative 3 to negative 0.718 union 1.99 to 3, right? Right here you can include the endpoint right here, negative 3, and the right hand side should be 3, right? Now question 2 and question 3, you're going to do exactly the same thing. All right, so I just leave it as your practice. Now let's move on to the last one right here. Number 1. Which of the following statement about the zero of the function f is correct, right? Now look at this one. We have 1, 0, right? We have two imaginary 0 right here, s squared plus 4. S squared plus 4 equal to 0, right? So it's going to be s equal to s squared equal negative 4. So we have two imaginary 0. Two non-real 0, right? So we look at this one right here. We see that two non-real 0. So we need to eliminate A and B, right? Now, we look at this one right here. We have the 0 is going to be s equal to 0. This one right here, we have the 0 s equal to 3. This one, we have s equal to 1. So we have 3 distinct real 0 and 2 non-real 0. So the answer must be C. On to question 2. Given a function g of x, on what intervals is g of x greater than or equal to 0, right? So we need to factor this one out, right? So we have a times c equals 2 times negative 12. It's going to be negative 24. And b equal to 5. Now we need to find two integers, multiply equals negative 24, add up to 5, it's gonna be 8 and negative 3. Alright, so I have s plus 8 times s minus 3. Now I look at this one, I see that the leading coefficient is 2, so I need to divide this guy by 2, this guy by 2. I simplify 8 divided by 2, it's gonna be 4, so I have s plus 4 times this one. I cannot divide 3 by 2, so I need to multiply this one, so it could be 2s minus 3. Now I need to find the zeros of this one, so the zeros should be negative 4 and 3.5, right? So I put this guy on the number line. It's gonna be negative 4 here, 3.5 right here. The left hand side is negative infinity, the right hand side is positive infinity. I put the line right here. Alright, so I pick a number within this interval, so I pick 0. I substitute over here. Right, so I have 0 plus 4 is going to be 4. 0 minus 3 is going to be negative 3. 4 times negative 3 is going to be negative. So within this interval it's going to be negative. So I look at this one, I don't have the even multiplicity of the linear factor right here. So I keep changing the sign. So this guy should be positive, this guy should be positive. Now I look at this one right here. I need this guy to be greater than or equal to 0. So my answer should be this interval and this interval. So it's going to be negative infinity to negative 4. And then union 3.5 to infinity. Right here I put the parentheses, but right here I put the bracket, because these guys right here are both 0 of the inequality right here, and this guy right here we need greater than or equal to 0, right? So the answer must be D. Now question 3. The polynomial function has the 0, 3, multiplicity of 2, negative 4, multiplicity of 3, this guy. What is the least possible degree of this one? Alright, so we need to start from here, right? The function h of s has the 0, s equal 3, alright, s equal 3, and then we subtract 3 both sides. Okay, we have the linear factor s minus 3 equal to 0. So s minus 3, right? Power of 2, because the multiplicity of 2. Now, next one, s minus 4 multiplicity of 3. So I have s equal to negative 4. Add 4 both sides. S plus 4 equal to 0. So I have s plus 4 right here. Multiplicity of 3, so I put 3 right here, power 3. Now I have the next one, s equal to I. This is imaginary number. So whenever you have imaginary root, its conjugate must be the second root. So keep that in mind. If you have a plus bi is a root, and its conjugate is a minus bi, must be the second root. So we have s minus 2i, right? And then the other one should be s plus 2i, right? And the last one right here, this is same thing, s minus 5 minus 3i, and s minus 5 plus 3i. Alright, so now we're gonna check the degree, right? This is power 2, power 3, this is power 1, power 1, power 1, power 1. So it's gonna be power 9. So the answer must be D. Question number 4. The graph of the function h is shown above. Which of the following statements about the function h is correct, right? So we look at the rate of change of h is positive, we draw the tangent line right here, right? And we see that the tangent lines go in this way, which means the slope is negative, right? This guy's slope is positive. So because the slope is negative, the rate of change is negative, right? So we need to eliminate the answer A, right? Answer B, the rate of change is negative, which is right, and decreasing. We draw another tangent line. Right, we draw another tangent line right here. And if it's going this way, if the tangent line getting steeper, the slope is smaller, right? Which means it's decreasing, right? So the answer must be B. Now, question number 5. The function case is given. Which of the following statement about the zero and multiplicity of k is correct? Right? So we just factor this one. It's going to be s minus 3 times s plus 3. This one already linear factor, so s plus 3 cube square. And this guy turned out to be s plus 3 square right here, right? So we just combine them. It's going to be s minus 3 times s plus 3. So we see that 1 plus 2 plus 2 is going to be 5, right? So we look at this one, the 0 must be s equal to 3, s equal to negative 3, multiplicity of 5. So the answer must be A. Now look at number 6. Given this table, which of the following statements pairs about the function g could be true? Okay, the function g is an odd function and the graph of the function g is concave up. So we need to find the average rate of change, right? So this one right here, we need to add 2, add 2, add 2, and add 2. The right hand side right here, we need to add 1, add 4, add 5, add 6, right? Okay, so we need to find the average rate of change of each interval, right? So the first one is going to be 1/2, the second one is going to be 4/2, the third one is going to be 5/2, and the last one is going to be 6/2, right? And we see that the average rate of change is increasing, right? So because the average rate of change is increasing, the function is concave up. So because the function is concave up, we need to eliminate A and C, right? Now next one. In order to know if the function is odd or even, we apply the formula f of negative s is negative f of s. This is odd. F of negative s is f of s. This is even, right? This guy right here. So I have g of negative 1 equals negative 3, right? Now I have g of negative 1, which means negative s right here. Negative 1 is g of 1, right? But g of 1 equal to 3, right? And this one equals negative g of negative 1, right? So I just prove that g of 1 equals negative g of negative 1, right? Which is the formula right here. So the function is odd. The answer must be B. Now let's move on to the next question. Question number 7. Right, given the function is even, right? So if the function is even, you have f of negative s equals f of s, right? So which means s opposite, right? S opposite, and then the output must be the same, right? Same output, but opposite s value, right? So we look at this one right here. We look at A, right? Same output. Now look at this is 2, and then we need opposite s value right here, right? Same output, so A equal to 1, right? Now B, b right here, and then I see that the output is 5. I look at the output right here 5, right? So b right here must be opposite to -3, so which means b equal to 3, right? Now c right here, c, and I look at the input right here 6, and then input must be opposite, right? So 6 and -6 right here, so c must be equal to -4. So -4. So if you add them up, the answer must be 0. So the answer is C. All right. Look at number 8. The function, which of the following statement about the function g is correct? The function g is increasing at an increasing rate, or something like that. Okay, so you just draw a tangent line right here, and you use the Christmas tree trick, right? The tangent line is going this way, the slope is positive, the function is increasing. The tangent line is going this way, the slope is negative, the function is decreasing, right? So because the tangent line is going this way, which means the function is decreasing. So I eliminate A and B, all right? Now, I need to draw the second tangent line right here, and I compare the slope of this guy and this guy, all right? So because this guy right here has smaller slope of this guy, because this guy is steeper than this guy. So if this guy has the smaller slope of this guy, which means the slope is increasing, right? So the function is decreasing at an increasing rate. The answer must be C. I'm going to leave question 9, 12, 11, 12 for you to practice. Let's move on to question number 13. Let the function f be an odd function such that f of -4 equal to 5 is the location of local minimum. Which of the following statements must be true? All right. So because the function is odd, right, we have f of -s equals -f of s. So which means the input opposite and the output is still opposite, right? Because they both symmetric about the origin, right? So we look at this one. This is -4. This turned out to be 4. This is 5 turned out to be -5, right? So I have f of 4 equals -5, right? And this is local minimum. This guy becomes local maximum. So the answer must be B. Alright, so I'm going to leave question number 14, 15 for you to practice. Right, this is similar to the previous one. Now question number 16. We need to write the polynomial function of this one right here. So we need to find the 0 right here, the 0 right here, the 0 right here, right? And we see that this guy piles off the x-axis, so this guy right here has the multiplicity of 2, right? This guy has the multiplicity of 2, and this guy multiplicity of 1. So total must be degree 5, right? So I look at this one right here. I see that this is degree 1, degree 1. So this is wrong. Degrees 1, 1, 1. This is 3, so wrong. This is 2, 2, 1. So this could be right. This guy 2, 2, 1. This could be right, right? Now I look at the end behavior right here. This guy and this guy opposite end behavior, which means the leading coefficient is negative. So the answer must be C. Alright, now number 17 all the way to number 24. I'm going to leave it for you to practice. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun, as she puts her hand in mine.